pick up their work later. Okay? So we're calculating these averages, and then we're going to record them on the second document on this assignment called Greenhouse Data Analysis. So find the averages for yourself. I'm not going to do the math for you. So you can always check your work when you're doing an average by seeing if your answer ended up in the middle of the rest of that group of numbers. If it's not in the middle, then you know you made a mistake. And so I put some estimates at the bottom of the page. If your answers are in that range, then it's probably a good answer. For example, I am estimating that the covered bottle before we put it outside should average in the low 70s. Definitely, it has to be greater than whatever the lowest number is, but it has to be less than whatever the biggest number is. So it has to be somewhere between 69.9 and 75.2. Similarly, the open one beforehand has to be between 68.0, that's our lowest number, but it can't be any more than 71.4. So that's one way that you can kind of check your work when you're doing averages. It should always come out in the middle. So this is the new document that I added to the assignment where we are going to record this data. We're still going to turn in the old document also, but parts of it we're going to skip, and we're going to do this for our analysis instead. So this is where you're recording your averages. And I want you to add a column that says change in temperature. So you just subtract to get that change in temperature. If it's a positive number, then that means it got warmer. If it's a negative number, it got colder. So you're going to go starting minus ending to give the change. And then you need to write some kind of a professional scientific title that describes what this table is showing. A scientific title is usually a full sentence that includes all the variables so that the reader knows what is going on. You're not writing that for yourself. You're writing it for someone that looks at it later. So if they weren't here, they should be able to understand what was done. So what were we comparing? Oh, the bottle as if they were open or closed. That's one of the variables you should include in your title. What were we measuring? Oh, their temperatures. When did we measure the temperature? After all that time in the sun. So those are things that should be part of this complete sentence that makes up the scientific title. Some good phrases to use in titles like these are a comparison between, or the influence of. These are some good phrases to include in titles, scientific titles like this. And you're going to have a second one to write for the graph of this data that we're going to show below. Okay, let's talk about this graph. On any good graph, across the x-axis on the bottom is where you're going to put the cause of any changes. The cause is going to go across the x-axis, and the effect or the results are going to be on the y-axis. So the first thing you always have to think about is what's going to go on the x, what's going to go on the y. What was the cause of any changes that happened? Yeah, what were we comparing, in other words? Covered and uncovered, right? So this is like the condition of the bottle down here, isn't it? And you need a title down there that says what this is. And what was the effect? What did we measure? Yeah, so this is going to be temperature on the side, huh? Well, let's think about those temperatures. What was the lowest temperature that we ever had? Pull that back up here. We have to make sure that our full range of temperatures will fit. And it looks to me like the lowest number I see on there is what, 46.2, right? So we have to make sure that fits on there. And our highest number, 86.0, has to fit on there also, huh? We're not graphing these individual data points. We're just graphing the averages, right? You're going to have four points on here. And what do you think? when we're graphing these, should we show them as a line graph or as a bar graph? In this case, what's the best way to display this data? Let me give you an example of a line graph. If the numbers can be interconnected between one point and another, right? If I have something like this, and these can be interconnected, for instance, if this was time, or maybe this was temp, because there's something in between the numbers, it's possible, right? Is there something between 50 degrees and 60 degrees? If the answer is yes, then you use a line graph. But wait, you have to ask yourself that question only about the x-axis. So just because we have temperature on the side doesn't make it a line graph. The other option is the bar graph. You look at what's on the x-axis, and for us it was what? The bottle, condition of the bottle, right? And what did we have? We had either open or we had closed. Yeah? Was there anything in between? Was there anything that was halfway open? Or were they totally separate categories? If they're separate categories, that's when you use a bar graph. Okay? So think about that. What seems the most appropriate for this data? Next, I'm going to look at how many boxes I have here. 1, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 boxes to work with. It's quite a bit. And that easily could accommodate all the numbers I need if I counted like 5 each. So I would start with 0, then every second one would be another 10 degrees, Every second box is 10 degrees more. And that will fit all of my data easily, and then beyond too. Now it's really important that you label what the x-axis shows. What is this value down here? In this case, and in many cases, it's 0. But like we did a graph the other day in my physical science class, that this was like 10,000 at the bottom. That's why you have to label it. So make sure you include the 0. That's something I always check for, is did you label that axis value? Okay, and then you should end up making 4 different bars, 1 for each of our averages. All right, you need a bar to show each of those 4 data points. Okay, now one easy way to make really nice bars, if you have this same program that I do, is you don't draw it by hand. Instead, use this function to make a rectangle. And you can change the color of it in a minute. Let's say I had something that was at 45 degrees. I can make a very nice rectangle like that. Now, I think I want this to be filled in solid, so I right-click, I click on Properties, and it takes a minute to come up. But then I'm going to tell it to fill in with red. Boom, I have my red box. A bar at the right size. Right? Yeah. Let's do another rectangle over here. I'm going to make this one be 75 degrees. Did you see how I got the rectangle? Let me just do that over again. Control Z. I use this command or something like that. That's going to allow me to draw shapes. I chose rectangle, and actually I can just draw it anywhere. And when I'm done, I can drag it to where I want it to be. There we go. I have to make it do that. Here it is. Oh, wait, I wanted it to be 75. I better make it taller, huh? Now to change it, I right click on it. I click on properties. I'm going to make this one blue. This is going to make the outside edge blue, but to fill it with blue, I have to change the fill color and tell that to be blue also. Okay, so go ahead and take a couple of minutes to make that graph. Make sure everything is labeled on there, which is before, which is after, which is open, which is closed. You can do that either with labels or you can make a key. Yeah. So did you find a way to make a box? Shapes. Yeah, yeah. Change it to the size you want, and right there, shape fill will change the color of it. So you'll end up with 4 different bars, one for open before, one for open after, one for closed before, and one for closed after. After you've done the bars, there's these 4 things that I've typed in red that you need to make sure you've added to your graph. And then at the bottom, you're going to write a conclusion of what happened. Okay, so after you've done these 6 things that I've typed out on the board here, then you'll be ready to turn this in, and then we return to the original document that we started on. Okay, so this one is ready as soon as you've finished writing your conclusions. Don't forget those titles. So if we look at the original document, we've already finished the first page. We've already finished the second page. The third page, well, we did this on that separate document, so we're not going to do this. And the conclusions you also did on that separate document. Okay, so we're going to skip the top half of the third page. I do want you to answer these 3 questions on page 3. We've already done 4, 5, and 6. And then on the last page, there's only one thing I want you to do, and it's this last one right here. Actually, this number 2 is good too. Let's do this one. We'll skip number 1. You don't have to worry about any of this. Skip all that. But we will do questions 2 and 3 in the very end. What do you think? Did the bottles show the greenhouse effect? Well, when I look at it, it's kind of subtle because the covered one, it got a little warmer, didn't it? Not a lot. But the open one not only didn't get warmer, but it got much colder, huh? So all of this loss of temperature of about, what, 20 degrees, 15 degrees, all of this loss of temperature was made up for by the covered one, in addition to any heat that it gained beyond that. So I would argue it did show the greenhouse effect. So one more time on the analysis. You're done when you've done these 6 things listed at the bottom. Labeled the numbers on the graph, you drew the bars, you labeled the bars, put titles, 3 different titles, 1 for each axis, and the overall title. You made a key, which shows, for me, it would be what's red, what's blue. And you wrote your conclusions down here at the bottom of the paper. And then that page should be saved and then uploaded. When you're done with that, we're going to this page, and I don't know, we could do this at homework, but I thought I would just give you class time to do it. Basically, you need to answer these 3 questions on page 3 and the last 2 questions on page 5. So I'm going to add that to my list of things to do over here, so you'll know when you're done. So I'm going to give you 5 or 10 minutes to finish all of that, and then we're going to move on to a new assignment. Answer all three of them. On page 3, all three questions. No, it's not. It's because yours compresses on your computer, and it doesn't look like my page. Skip all that. I want you to do 2 and 3. Yeah, go back up. I want you to do these 3. Oh, did you already do that? Great. All right, how we doing out there? Getting close to being done? So if that little plastic bottle contraption was able to trap that much heat in that short of a time, just imagine how a regular greenhouse works. Or you know what it's like in your car. It was quite warm in my car at lunchtime today. It's the same thing, right? The glass is invisible to the visible light. The light we can see passes right through it, huh? And then that energy is absorbed by the seats in the dashboard, or in the case of Earth, by the land and the oceans, absorb the heat from the sun, the light from the sun, really. And then the absorbed energy is converted into heat energy, which is released. But greenhouse gases, including CO2, methane, water vapor, and others, trap that heat, and the temperature rises. And so what we're going to do at this point is move on to look at the data that scientists have gathered in relation to climate. We've looked at the carbon cycle in order to see how people have been moving ancient carbon from underground into the air, which must have some impact, right? If we're taking all that ancient CO2 out of the air, out of the ground, moving it in the air, must be doing something. We've looked at CO2 itself and some of its properties, including its ability to trap heat. We've demonstrated the greenhouse effect now, huh? So now we're going to look at the data that scientists have gathered and how they gathered it, comparing today's climate to past climates, looking for trends and using those trends to predict what could potentially happen in the future. So you should find a new assignment on Teams called CO2. What does the data say? Something to that effect? Or climate change. What does the data say? That's what it says.